All right, today we want to do some calculations in mole concept in core chemistry. But before we do the calculation, we want to look at some basic terms in mole concept. First of all, let us define mole. Mole is the amount of substance containing Avogadro's number of particles. The students can also be asked to define Avogadro number. And when we say Avogadro number, we say is the number of particles present in 1 mole of any substance. Now, let us also look at another term called molar mass. Molar mass is the mass of 1 mole of any substance. Its unit is gram per mole. So anytime you have been asked to calculate for molar mass, the unit you use is gram per mole. Okay, let us also look at the mathematical formula for molar mass. Molar mass is equal to mass of the substance all over amount of the substance. And from here, we can give you the molar mass, give you amount of substance, and ask you to find mass. So it's just change of subject. You make mass the subject, then you can get whatever quantity you want. Now, let us also look at another term here called formula mass. Formula mass is the summation of the relative atomic masses of the individual atoms present in a molecule or compound. One thing about formula mass is that formula mass has no unit, but molar mass has unit. And we can use the principle of formula mass to calculate for molar mass in some questions. Now, let us look at a question here. Determine the molar mass of each compound. We have HCl, Na2CO3. We have NaHCO3. We have Ki. We have NaCl. We also have NaOH. We also have H2SO4. And they give us the relative atomic numbers or masses of the individual element. So we are going to use concept of formula mass to determine our molar mass in these cases. Let's see how we can do it. Molar mass of HCl equal to, now the hydrogen that we have here, its relative atomic mass is 1. The chlorine that we have here, its relative atomic mass is 35. So if we have been asked to find the molar mass using the formula mass approach, we are going to sum them. So here is H plus Cl. The H represents 1 plus our Cl represents 35. So we add the two, which will give us 36 gram per mole. Now let us also say this. Molar mass of Na2CO3 equal to, now here we have 2 here, which is multiplying Na, which is the sodium. So in mathematical representation, we use the 2 to multiply the Na, and Na, its relative atomic mass is 23. So we have 2 times 23 plus our carbon, which is 12, plus now we have oxygen, and the number of oxygen molecules here is 3. So the 3 is multiplying the oxygen here. So we have plus 3 multiplying the 16. And when we fix this into our calculator, we are going to get 106 gram per mole. The same thing we'll also do for potassium iodide, which we have 39 plus 27, and that will give us 66 gram per mole. We can also have molar mass for NaCl, which the Na is 23, plus our Cl, which will be 35. When we add the two, we are going to get 58 gram per mole. Now, you can try, that is sodium hydroxide, and you can also try H2SO4. You can also try NaHCO3 and see whether you get your answers. After that, put your answers in the comment section and let's see what you get. Now, we have another question here. Calculate the molar mass of NaHCO3 if there are 4.2 grams of it in 0.05 mole So here we want to find molar mass, but we cannot use this principle here to determine our molar mass because we have been given the mass of the compound here, we have been given the mole of the compound here. So we need to use the formula that we study here to get the molar mass. So we say molar mass is equal to mass over amount of substance, which means that the mass is given, and that is 4.2. So we have our 4.2 here. The mole is given 0.05, and we have 0.05 here. So when we divide it, we are going to get 84 gram per mole. All right. So this is how we can also calculate our molar mass from this one that we had here. Now we have another question here. We can also determine that is molar mass of other compound as we can see here. So we have the molar mass of Al2 into bracket, you open bracket, CO3, you close it, multiplying 3. So we can also calculate our molar mass here as you can see. Thank you. All right, we have been given a question here also to look at in more concept. We have a solution was prepared by dissolving 20 gram of NaOH in 500 centimeter cube of distilled water. Now, we have been asked to calculate the concentration of the solution in mole per dm cube. So now we are looking for concentration. And we say if 100 cm cube of the solution is diluted to 1000 cm cube, calculate the concentration of the diluted solution in mole per dm cube. And we have been given the relative atomic masses of the molecule or the compound we have. That is Na is 23, oxygen is 16, hydrogen is 1. Now let us look at how we can calculate the concentration first. So first of all, let us look at some formulas here. We have concentration, and when we say concentration, mathematically is amount of substance all over volume. So we can say C equal to N over V. So this is the formula that we can use for concentration. But amount of substance equal to mass over molar mass, as we already studied in molar mass. So here from molar mass, we make amount of substance the subject, and we can also have N equal to M over big M. So we are going to combine these two formulas to calculate our concentration that we have been asked. Now let us look at how we can use these two formulas to get our concentration. So first of all, in the question, we have been given the mass. So we have 20 gram. We have the volume in cm cube, that is centimeter cube. And from the definition of concentration, where we say concentration is the amount of substance dissolved in 1 dm cube of a solution. So it means that the volume needs to be calculated in decimeter cube. So here we convert from cm cube to dm cube. And how do we convert it? We divide by 1000, as we can see, and that will give us 0.5 dm cube. So with this data that we have, we are going to calculate for our concentration. But before then, we need to calculate our molar mass also as well, so that we can use our molar mass, our volume, and our mass to get our concentration. So the molar mass of NaOH, we also calculate as 23 plus 16 plus 1, which will give us 40 gram per mole. All right, so let's see how we can do this calculation now. Now, we are looking for concentration, all right, which is equal to mole over volume. But in this case, we don't know our mole, but we know volume. So we want to calculate the mole first. So we say the mole of NaOH is equal to the mass of the NaOH all over the molar mass of NaOH. And in doing that, we have 20 divided by 40. All right, and that will give us 0.5 mole. Now that we know our mole, we can use this formula to get our concentration. So concentration is equal to mole over volume. So we say mole is 0.5. The volume we also convert here is 0.5. So when we divide it, we are going to get 1.0 mole per dm cube. So this is how we can combine these two formulas to calculate concentration. All right, from the II, we are also going to look at how we can calculate concentration. But this question is about dilution. All right, it's about dilution. And for we to calculate this question, we need to know some formulas about dilution. And we say that in dilution, the initial concentration times initial volume should be equal to final concentration times final volume. So we say C1 V1 equal to C2 V2. Now we need to know the initial concentration, initial volume, and final concentration so that we can see how we can use this formula to do our calculation. But first of all, let us go to the question and see what we can get. If 100 centimeter cube of the solution is diluted, so here it means that our initial volume is 100 cm cube. So we have V1, which is 100 cm cube, and we convert it to dm cube. So we divide it by 1000, and that will give us 0.1 dm cube. Is diluted to 1000 centimeter cube. So this is the final volume, that is V2. So our V2 is 1000. So we also change it to decimeter cube. So we divide this by 1000, and that gives us 1 dm cube. All right. And from the question, we have been given the initial concentration. We have been given the initial concentration. And the initial concentration is what we've calculated here, because here there's no concentration in II. But the concentration that we are going to use, which is CI, that is what we've calculated here. That's the initial concentration. So our initial concentration is equal to 1.0 mole per dm cube. So now we can find our C2, which is the final concentration. So from this, we can make C2 the subject. So we have 1.0 times 0.1 equal to C2 multiplied by 1. Making this the subject, C2 will be equal to 1 times 0.1 all divided by 1, all right, which is our our initial concentration. And when we multiply and we divide by 1, our final concentration will give us 0.10 mole per dm cube. Now, there is some information here which you can add to what we studied. During dilution, the initial amount of NaOH will not change. Therefore, the amount of mole present in the initial solution will be equal to the amount of mole present in the final solution. So we have mole which is equal to C times V. So here we can see C1V1 equal to C2V2. Thank you. All right. So these are some questions under mole concept for students to try. So you can try these questions and put your answers in the comment section. Thank you.